Today we're talking about inscribed angles. An inscribed angle is an angle with the vertex on the circle. Angle whose vertex is on the circle. So remember, we talked about central angles having their vertex at the center of the circle, and the angle was equal to the arc. And now inscribed angles have a vertex that's on the circle. And an inscribed angle cuts off a particular arc, and there's a relationship that exists there. This picture over here, this is also considered an inscribed angle because the vertex is on the circle, and the arc that's intercepted is the one in here. And if you trace that angle, you'll see the arc that's inside. So what we find out if we did this activity is that, let me go to the bottom of the page. We find out that the measure of the inscribed angle is equal to half the measure of the intercepted arc. The angle is half of the arc. So where we had the central angle was equal to the arc, the inscribed angle is half of the arc. Alrighty, there's another rule in here. If two inscribed angles intersect the same arc, so for example, we have angle 8, which intercepts arc BE. And then we also have angle 9 that intercepts that same arc. Guess what? Angle 8 and angle 9 are congruent to each other. So that was that rule. And at the bottom of the page, these two are pretty important. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. Supplementary. We'll practice that in our worksheet. If a quadrilateral is inscribed in a circle, the opposite angles add up to 180. The opposite angles are not equal. They add up to 180. If a right triangle is inscribed in a circle, and that is this example right here, if this is a right triangle, then angle 5 is 90, and that makes the arc that it intercepts twice as much, so it's 180. So if this is 90, it's half of the arc, which makes segment AB a diameter. So there we go. So those are the rules we're working with today. The inscribed angle is half of the arc. A quadrilateral inscribed in a circle, the opposite angles are supplementary. And let's run through some practice with that. So I'm over here on the page that's entitled Elaborate, and we'll walk through these practice examples together. Now, one thing to notice on these worksheets is anytime it just says MVW, that's referring to the arc. If there's no angle symbol in front of it, it's referring to the arc. So just know that that arc is missing because there's no way on the computer to put it there. So C is the center of the circle in all of these. So you want to notice a couple of things. Always look for diameters because we know a diameter cuts it into 180 and 180. And then we can look for other things after that. I like to label my picture first and then go answer the questions. So here goes. If this angle right here is 17, angle WTV, I'm going to look at what arc it intercepts, which is WV. So if you name the angle WTV, the arc that's intersected is WV, the two outside letters. So the angle is half of the arc. So my arc must be 34. Now notice that from W to T is a diameter, or is a semicircle. So 180 minus 34 is going to give me 146 because that adds up to 180. Now I'm going to look over here at this 65. The 65 65 cuts off the arc that goes from W to S. So I know that 65 is half of this entire arc, and 65 times 2 is 130. So 60 plus what gives me 130? Arc WR is 70. And the only arc I have left is ST. So remember, from W to T was a semicircle. So 70 plus 60 plus 50 gives us our 180 for that semicircle. And you can double check and make sure all your arcs add up to 360. That's always a good idea. So we can go answer the questions now. Arc VW, 34. And you can put degrees on that. If you don't put degrees every time, that's going to be okay. Arc WRS. Remember, that's a major arc. So I want to go from W to R. Well, actually, it's not a major arc. From W to R to S. There's just an extra letter in there. So that adds up to 130. The arc from W to R we found was 70. The arc from S to T was 50. And the arc from V to T was 146. So we found all of those first. Now let's answer these angles. Angle V. So I want you to notice that angle V has a vertex on the circle. So it's going to be half of the arc. I just have to figure out what arc is intercepted. It's right there. So if you trace the angle, then you can tell what arc is intercepted. So it's this one. I had the 60 and the 50, which is 110. The angle is half of that arc. So it's 55 degrees. Angle VRS. VRS, I'm going to do the same thing. VRS is this arc right here that looks like 196, and half of that is 98. So you want to look really carefully, where's the vertex of your angle, and then what arc it intercepts. All right, let's move to question 2. Very similar. We've got angles and arcs, but notice there's no diameter here. So nothing goes through the center, so we don't have a definitive diameter. So we would need to know that. And remember, if there's no angle in front of it, we're asking you for the arc measure. All right, so let's start with arc. I can't do a whole lot in this circle because I don't know the arcs, so we'll just work piece by piece. Arc AE. I notice that angle B is 21, and arc AE is the intercepted arc, so the arc is twice as much as the angle. So remember, the angle is half of the arc. Arc BF is over here, and that looks like it comes from angle E, which is 52. The angle is half of the arc, so BF must be 104. Arc AB. Well, I don't have an angle that goes to arc AB, but take a look. I know every arc in the circle except this one. So I add all these together and subtract it from 360 and find out that arc AB is 98. And now we can answer the rest of these questions. Angle 1. Notice angle 1 has a vertex on the circle. It's going to be half of the arc. And if you trace angle 1, it goes out to B and to F. That arc was 104. Half of that is 52. Arc EBD. EBD cuts off this arc, which is 75. So half of 75 is 37.5. Just take your time, work carefully, and you should be okay. Number 3, find X and Y. Well, this picture looks different. It looks like we've got a tangent line here. Remember, we had a rule that said the tangent line and the radius make 90 degrees, but I don't see a radius, so I'm not going to use the 90 degrees here. So let's think of what we can do. Well, I know that angle A is 40, and angle A goes to C and to B. So this arc right here is the one we took half of to get the 40. So I'm going with arc BC is 80. Now that's going to help me find angle X because angle X is right here. And the arc that it cuts off is the 80 that we just found. So x is 80. So there's a couple of different ways we can find y. We can just use the circle. I've got 150 and 80. If I add those and subtract it from 360, I get 130. So angle y is half of 130. So that's 65, not 75, 65. The other way to do that, here's where I was thinking 75. This angle over here is 75 because it's half of 150. And if I add those and subtract from 180, I get y is 65. So there you go. All right, next up. Number 4, find all the values of all the variables. Okay, we can do this. Notice, look at the diameter. Diameter cuts a circle into 180 and 180. So I know right away B is 100 and that's D is 150. So now I can just start finding my angles. If I start with A, notice A goes right here and to here, and the arc that it cuts off altogether is 180. That makes A 90 degrees. Remember the rule that said if it cuts off, if the hypotenuse was a diameter, then this must have been 90 because it cuts off a semicircle. Let's look at M. M, if you trace it, it goes to the 80. The vertex is on the circle, so it's half of the arc. So M is 40. How about F? Doesn't F cut off this 100 right here? So F must be 50. And that makes sense because I've got 90, 40, and 50 to make this triangle. Now look at angle E. Notice where the vertex of angle E is. It's at the center. And we know that central angles equal the arc. So E must be 30 degrees. Now right over here where we have N, it's not an inscribed angle exactly like the others because it doesn't go all the way through. So it's just right there. I think I'm going to use a triangle for that one. So if E was 30, then this must be 150. That's really tiny, sorry. And then this is a radius, and this is a radius. So I have an isosceles triangle, which I'm not drawing very well. But if that's 150 and it's isosceles, subtract 150 from 180 and find out that N is 15 degrees. So we divide by 2 to get those base angles. So you're looking at everything. Always, you're looking for triangles, you're looking for diameters and arcs and where the vertex of the angle is, all things you need to pay close attention to. Now, question number 5 has a couple of really important things in it. So let's chat about this one. Okay, again, if there's no markings, if there's no angle symbol, they want the arcs. So we look at this picture. I see a trapezoid and it is inscribed in the circle because every vertex touches the circle. That's important. Now here's a rule we didn't mention the other day that we need to mention. We've got these parallel lines. Parallel lines do all kinds of cool things throughout our geometry years. But one thing that parallel lines do is they cut off congruent arcs. So if the lines are parallel, the two arcs that are in between are going to be congruent. So if this arc is 70 degrees, this arc is 70 degrees. So you use those parallel lines. And alternate interior angles and all of those other things still apply. So here we go. The 95 is pointing to this entire angle, just so you know. All right, let's start with angle 5. Angle 5, vertex is on the circle. So you look over to the arc. Arc is 70. So angle 5 must be 35. We'll look at angle 4. Does an angle 4 go to a 70-degree arc? So it must be 35. Okay. Now, how am I going to find these other arcs and angles. Let's see what we can figure out. We know that this angle is 95. So because of our rules of parallel lines and trapezoids, this angle and the angle down here must add up to 180. They're same side interior angles, so they are supplementary. So angle 3 must be 50. 85 plus 95 gives us our 180, which means over here, angle 6 must also be 50. That's good to know. And that helps me with a couple of things. Angle 6 is pointing up here to arc AB. Remember, the angle is half of the arc, so this must be 100. And now I look at my entire circle, 70 plus 100 plus 70. Subtract that from 180. This arc at the bottom is 120. And that's going to help me with angle 1. Well, angle 2 goes to the 70 over here, so it's 35. And if I know angle 1 has to be 95, it makes sense that angle 1 is 60, which is half of the 120. So we now have answered every question. Arc AB is 100, arc BC is 70, CD is 120, and then we can fill in all of the angles that we just calculated. So those are some ideas for you as you go through your inscribed angles lesson and worksheet. Please do the practice sheet before you attempt the exit ticket. And remember, you only have one shot at that exit ticket, so don't click begin until you're really ready to begin. Have a great day.